It's hard to get to, potentially hostile, decidedly slippery, almost unimaginably vast, and shrinking rapidly. This ice was up there in April, and it's now down here.
Yeah.
Greenland's ice sheet is one of the hardest places there is to work. So just why are scientists heading here in force this summer? Well, from the heat waves we're experiencing right now to the prospect of Scandinavian winters in Britain in future, it all comes back to the Arctic's largest ice sheet. But this 600-mile ice-covered island doesn't give up its secrets easily.
So the longest road in Greenland is only 35 kilometres. So if you want to get pretty much anywhere, it means taking a helicopter.
And it's only once we're airborne you get a sense of how much ice there is.
That's the Greenland ice sheet, and it just looks like it goes on forever. Just ice, ice, ice as far as the eye can see. It's just absolutely incredible.
When we land, there's the locals to deal with.
You can also see 2 muskox, so we'll have to be cautious of those.
More closely related to goats than their name suggests, shy, shaggy, 400-kilo goats with a bad temper.
And the distance is good. I mean, we're quite far off, right?
Yeah, they'll be fine, yeah.
Working on Greenland's ice sheet means hauling a lot of equipment, not just for science, but survival. Polar bears are rare here, but far more dangerous than muskox.
There have been a few bears around Kanga in the past couple of years. It's basically better safe than sorry.
The chopper can only carry so much, leaving us to walk to camp. After a night's sleep in a place where the sun doesn't set in summer, we head towards the thing they're here to study.
Look at that. This glacier, it's like a vast tongue of ice. It must be at least a couple of kilometres across. And that's just one of more than 900 large glaciers coming off the Greenland ice sheet, and there are thousands more smaller ones.
You drop one in the water. Field work in such a hostile and treacherous place is part science, part mountaineering. These researchers know better than most how fast Greenland is melting, but even they're surprised when we reach the monitoring station they installed at the end of winter.
This solar panel, when we installed the station in April, was at the ice surface.
Whoa, so you're telling me in 3 months, basically, the glacier has melted by that much?
Yeah.
But that's not why these teams of scientists are braving Greenland's cold, inhospitable ice sheet. They're here to predict how it threatens to bring similar conditions as this to where we live, carried on a flood of meltwater.
Every trickle, every stream up on the ice comes together into one river, this river. And just looking at it, you can understand how in a big melt year, up to 500 billion tonnes of water can flood off the Greenland ice sheet and out into the sea.
So much water, in fact, it might be messing with something, wait for it, called the Atlantic Meridional Overturning Circulation, or AMOC.
The AMOC is like a giant heat-driven conveyor belt of water. Warm, salty water flows north from the tropics, shedding its heat into the atmosphere, warming the climate around Northern Europe and the UK. As it reaches the Arctic, the water cools. Cold water's more dense, so it sinks down and begins a slow journey south again. This vast convection current redistributes a mind-blowing amount of heat, around 1.2 petawatts. That's 60 times the amount of electricity produced globally each year. But there's evidence the rapidly warming Arctic is causing the AMOC to slow down. Some experts predicting a fast approaching tipping point beyond which it will slow irreversibly or even stop. A massive icy piece of the jigsaw is Greenland, more specifically what's known as the cold blob of ocean off its coast. Each year, an average of 200 billion tonnes of water melts off Greenland's ice sheet. Even though it's cold, this fresh water floats on top of denser, salty seawater. One theory is this pool of fresh surface water is like throwing a liquid spanner in the works of the AMOC, blocking the flow of warmer water, cooling and sinking and heading south.
And the more Greenland melts, the more the current slows.
And we end up with a climate, in wintertime at least, in northwest Europe that's similar to Greenland, minus 20 in London in the winter.
The stakes couldn't be higher, but scientists and their computer models don't all agree on the future of the AMOC. What they need is better data on how fast Greenland goes from ice to ocean. This team of scientists we're with is one of several heading out onto those glaciers this summer to get that much needed data on Greenland's melting. Trialling a network of stations on the ice sheet that use seismic sensors to listen to water running deep below the glacier. And instruments they've built like this cryo-egg that can track the flow of water through subglacial streams hidden within the ice.
Temperature increases this much, we know this much ice will melt. Does that then go straight out underneath the ice and down to the ocean, or does it get stored and take a little longer to be released? And that's what cryo-egg can tell us.
It's science on the edge. Dropping instruments into these tunnels of meltwater called moulins takes experience. One slip and there's little chance of escape. Not an easy thing to try and film either. Sending our camera into this terrifying opening in the ice without falling after it. What strikes you is just how much effort it takes to understand the melting of just one tiny part of Greenland's never-ending ice.
So we need to know all these seemingly like tiny little things to add up to the big picture, which is basically how much ice is going to melt, how is that going to cause the oceans to change.
That's why this project is part of a Greenland-wide campaign launched this year by the UK research body ARIA. The most ambitious part led by the British polar research vessel Sir David Attenborough. The floating laboratory is headed to the opposite side of Greenland, where glaciers flow directly into the ocean. The SDA is carrying a boatload of robotic technology that promises to transform Arctic research by gathering data in places too risky to access with crampons and ropes. A remotely operated launch will fix instruments to glaciers' unstable ice fronts. Aerial drones will measure melting from above, and marine ones, remember Boaty McBoatface, will analyse beneath the waves.
We need to get the physics of all of these different processes right in those models. That's why there is this big programme of work now, not only to measure and directly observe the ice melt in Greenland, but then to link that up with models to a big predictive model that would give us that information.
A weakened or even broken AMOC current would have almost unimaginable consequences for things like agriculture and infrastructure. But the best estimates suggest it'll take decades, maybe even a century, before we feel the full effects of an AMOC collapse. However, Greenland's melting isn't just a future problem. We're feeling its effects right now.
While all this ice might seem like the perfect antidote to heat waves across the UK and Europe, there's now good evidence the two things are linked. Where Greenland's cold meltwater meets the warmer AMOC current, it creates a sharp temperature front in the ocean. Research now shows this warm-cold contrast has a powerful influence on the atmosphere above it, including the jet stream that steers weather systems over Europe, like drawing Saharan heat northwards, causing heat waves. The phenomenon has now been linked to a devastating heatwave-induced storm in 2022 that brought strong winds, giant hailstones and flooding to Central and Southern Europe, and the Spanish 2024 floods, where a year's worth of rain fell in a day in parts of the country. But when that ocean temperature front shifts further north, it causes a loop in the jet stream over the UK, also called an omega block. It draws hot Saharan air even further north, precisely the conditions we saw in June that brought record-breaking temperatures and intense thunderstorms to parts of the UK and Northern Europe and led to thousands of heat-related deaths. and the same conditions behind the latest heatwave.
With future Greenland melting, we expect more intense and more frequent heat waves, especially in southern Europe, but occasionally also in northwest Europe, like now. So probably in the future, we will think that the heat waves we're experiencing now, we won't regard them as extreme anymore because they are going to be even more extreme.
Scientists like Altmans think it should be possible to predict when, and to a certain degree where, European heatwaves might occur. And just like trying to predict the long-term, wide-reaching impact of the AMOC, their models need better data on melting. Data researchers like Liz Bagshaw and her team are working so hard to get.
Every day we kid ourselves that we're going to be back for dinner at 7, and then we never are.